Section 6.2.35-T. According to an airline, flights on a certain route are on time 80% of the time. Suppose 11 flights are randomly selected and the number of on-time flights is recorded. We want to explain why this is a binomial experiment. Okay, so let's go ahead and discuss the requirements. An experiment is said to be a binomial experiment if each of the following statements are true. 1. The experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. Number 2. The trials are independent. This means the outcome of one trial will not affect the outcome of the other trials. Number 3. For each trial, there are two mutually exclusive disjoint outcomes, a success or failure. And number 4. The probability of success is the same for each trial of the experiment. Now, determining whether the experiment satisfies the given criteria. Well, this experiment is performed a fixed number of times since there are trials. There are, in this case, 11 trials. The randomly selected flights. The trials of this experiment are independent because each flight was randomly selected and no flight's arrival depends on any other flight. There are only two mutually exclusive outcomes. Either the flight is on time or not. And the probability of success and on-time flight is the same for each trial because flights on this route are on time, in this case, 80% of the time. Since the four requirements are satisfied, the probability experiment represents a binomial experiment. Okay, now in part B it says determine the values of n and p. Well, n represents the number of trials, so we know there are 11, so n is going to equal 11. Okay, and p represents the probability, so we know that p is equal to 80%, but we need to convert that to a decimal. So that's going to give us 0.80. So therefore, there are the values of n and p. Okay, now for part C, it says find and then interpret the probability that exactly 9 flights are on time. Okay, so to find the probability that exactly 9 flights are on time, remember that the probability of obtaining X successes in n independent trials of a binomial experiment where the probability of success is P is given by the formula below. Okay, so here is the formula. Now, exactly is a key word in this particular question. Okay, again, we know that n is equal to 11. We know that p is equal to 0.80. And we know that x is equal to 9. And again, we're looking at exactly 9. Okay, so that means that we're looking for the probability of 9. And now we're going to plug it into our formula. So we know that there's 11 trials, combination of 9, and then we're going to multiply that by the probability of 0.80 to the power of x, which is 9, and then times 1 minus 0.8, so 1 minus 0.8 to the power of 11 minus 9. Okay, so let's go ahead and put that in our calculator. Okay, so we're going to use 11, so we're going to hit 11, we're going to go to math, and then go to probability and scroll down to the combination. And the next value, r, which is x, is going to be 9. And then hit enter. And then we're going to multiply that by 0.80 to the 9th power. Okay, and then we're going to take that answer, and then we're going to multiply by 1 minus 0.80, which is 0.20. And then we're going to raise that to the power of 11 minus 9, which is 2. And therefore, that gives us the following result. Okay, so here is our answer. And we want to round this to 4 decimal places. So we have 0.2953. Okay. Now we can also use another option on the TI-84 calculator. Okay, now because it says exactly, then we're going to be able to use the function Binomialcdf, because P is going to represent the exact number. So we have our number of trials, we have our probability, and then we have X. So in this example, we have Binomialcdf. We know that the number of trials is 11. We also know that the probability is 0.80, and we know we have exactly 9. So let's go ahead and find that function on the calculator. So we're going to go to second, and then select distribution, and then we're going to scroll down, and you're going to see binomial PDF and CDF. PDF is the exact, CDF is cumulative. We're looking for the exact. So we're going to hit enter. The number of trials is 11. We know the probability is 0.80, and the value of X is 9. And then we're going to go ahead and select paste, and then select enter, and you're going to see that we get the same exact result. Okay. And now if we wanted to use StatCrunch, then we would do the following. So we're going to go to StatCrunch, we're going to select Stat, we're going to go to Calculators, and we're going to go to Binomial. Okay, we know that we have 11 number of trials. We know that the probability is 0.80. Now over here, we know that X has to equal, so we're going to scroll down to where it says equal, and it has to equal the value of 9. And then we're going to select Compute. And then when we select Compute, you're going to see that we get the same result for the probability there. So therefore, for part A, you can see that there's 3 ways of being able to get this result. Okay, so what does that tell us? Well, that tells us that the probability of 0.2953 is for 1 trial of this experiment. We would multiply by 100 to compute the number of trials of this experiment in 100 that are expected to result in a desired outcome. And you would use this information to reach a proper conclusion. So what we're going to do here, in order to use this information, we're going to take 0.2953, and we multiply that by 100, and then that gives us 29.53. Now we're going to round this up to the nearest whole number, which gives us 30. So therefore, in 100 trials of this experiment, it is expected that about 30 will result in exactly 11 flights being on time. Okay, part D, it says find and interpret the probability that fewer than 9 flights are on time. Okay, so the important phrase here is that the fewer means less than. And in this case, it's less than 9. So thus the probability that fewer than 9 flights are on time is equal to the probability of X is less than 9. So let's go ahead and write that out. That means you're finding the probability of X being less than 9, okay, which is equal to the probability of 8 or 7 or 6 all the way to 0. Okay, So how do we interpret this? That means we're going to find the probability of 8 plus the probability of 7 plus the probability of 6 plus the probability of 5 plus the probability of 4 plus the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of 0. Okay, so what that means is we're not going to include 9 because it doesn't say less than or equal to 9. Now, if it said less than or equal to 9, then we would include 9. But it just says fewer. So that fewer tells us that we're not including 9, so we're finding the probability of each of these and then adding them up. So what we're going to do is we're going to find the probability of each. Okay, so we know that n is going to equal 11. We know the probability is 0.80. So now we're going to find the probability of 8. Okay, so the probability of 8 is going to be 11 trials, combination 8. And then we're going to take 0.80 and multiply, raise it to the power of 8. And then we're going to multiply that by 1 minus 0.80, which we know is 0.20. And then that's going to be 11 minus 8. Okay, and then we're going to set up each one of these and then plug them into our calculator. So the probability of 7 is going to be 11 combination 7, which is 0.80 to the 7th power. And this is going to be 1 minus 0.80, which is 0.20 to the power of 11 minus 7. And then we have the probability of 6, which is equal to 11 combination 6, 0.80 to the power of 6. And that is the next one, which is 0.20 to the power of 11 minus 6. Okay, then we get the probability of 5, which is equal to 11 combination 5, 0.80 to the 5th power, times 0.20 to 11 minus 5. And then we get the probability of 4, which is 11 combination 4, 0.80 to the 4th power, times 0.20 to the power of 11 minus 4. Probability of 3, which is 11 combination 3, 0.80 to the power of 3 times 0.20 to 11 minus 3. Probability of 2, which is 11 combination 2, times 0.80 to the power of 2, times 0.20 to the power of 11 minus 2. Probability of 1, which is equal to 11 combination 1, 0.80 to the 1st power, times 0.20 to the 11 minus 1 power. And then the probability of 0, which is 11 combination 0, 0.80 to the power of 0, times 0.20 to the power of 11 minus 0. Okay, so let's go ahead and do the first one. All right, so we're going to go ahead and do the first one. So we have 8, and then probability, and then combination. Sorry, let me repeat that. That'll be 11 math probability combination, since that's n is first, and then that's 8, and then equals. So we have there. And then we're going to multiply that result by 0.80 to the power of 8. And then we're going to multiply that by 0.20 to the power of 11 minus 8, which is 3. And that gives us that result. Okay, so we're going to do that for each one. So I'm going to go ahead and pause it and then enter all the information and come back. Okay, so now that we've individually found the probability of each one, from probability of 8 to probability of 0, here's our values. We are then going to add each one of these probabilities up. So we have the probability of all of these. So here we take the individual probabilities, and then once we add them, we get our result, and then round it to 4 decimal places, which is 0.3826. So this is a long version of being able to get our probability, and it's important to be able to see this, right? Now, if we wanted to use a different function on our calculator, okay, so let me go ahead and put that up here. We're going to use the TI-84 calculator. Okay, what we're going to use is we're going to use the binomial. Okay, now in this case, since we are looking for 9, which is less than or fewer than 9, that means we're going to use now C, that's cumulative. So binomial CDF, and then we're using N, and then the probability, and then X. So that means that we're going to use binomial CDF. Okay, we know that the number of trials is 11. We know the probability is 0.80. But see, now the value of X is everything that is fewer than 9. Okay, so if we're looking for fewer than 9, we're not going to use 9. We have to start at 8. And then below. So that means that this number has to be 8. Okay, so let's go ahead and then put that into our calculator. So we're going to go to second and then distribution. We're going to scroll down now all the way to binomial CDF. We know our number of trials is 11. We know that our probability is 0.80, and then the X value is now going to be 8. So we need to make sure that we put that in correctly, and then select enter, and then you will see what we get for our result. So obviously this is going to get us our result a lot quicker than going through each particular one. And so therefore, this is our result, and if we round it to 4 decimal places, we're going to get 0.3826. Okay, now if we wanted to use StatCrunch, then we would do the following. Okay, let's go to StatCrunch. Okay, we're going to go to Stat, Calculator, and go to Binomial. We know that our number of trials is 11. We know that our probability is 0.80. And we know it's got to be less than. So we're going to use less than, okay, 9. Okay, because that's the probability that we have over here. We're not going to put less than 8. If we put less than 8, you're going to see that we get a different probability. This has to be 9 according to what we have over here. So therefore, you can see how we get the probability of being 0.3826 as well. So therefore, there is another way of using technology to get our result. Okay, so the probability, which is 0.3826, is for one trial of this experiment. So we're going to multiply this number by 100 to compute the number of trials of this experiment in 100 that are expected to result in a desired outcome. So if we take 0.3826 and then we multiply that by 100, then we're going to get 38.26, which rounds to 38. So then we would say that in the 100 trials of this experiment, it is expected that about 38 will result in fewer than 9 flights. And I think if I go back up here, okay, in this first question, okay, this should be in 100 trials, this experiment is expected that about 30 will result in exactly 9 flights being on time, because we were looking for exactly 9. So I was making that correction here. Okay, so now we're going to move on to part E. Okay, so part E wants us to find and interpret the probability that at least 9 flights are on time. Okay, so let's go ahead and discuss this. All right, so note that the phrase "at least" means greater than or equal to. So therefore, the probability that at least 9 flights are on time is equal to the probability of x being greater than or equal to 9. So we're looking for the probability of x being greater than or equal to 9. So whenever we have greater than or equal to 9, okay, as opposed to less than, we want to be able to find the complement. So what that means is we need to take the value of 1 and then we're going to subtract the probability of x being less than 9, which we already have done in the previous step. So therefore, what this is going to end up equaling is 1 minus, well, we found that to be 0.3826. Okay, so we're going to take 1 and then subtract 0.3826. So 1 minus 0.3826 is equal to 0.6174. So we end up getting the probability of 0.6174. Okay, so now that we found that probability, okay, the probability of 0.6174 is for 1 trial of this experiment. Again, we're going to multiply by 100 to compute the number of trials of this experiment in 100 that are expected to result in the desired outcome. And we're going to use this information to reach the proper conclusion. So we're going to take 0.6174. We're going to multiply that by 100 to get 61.74, which rounds to 62. So it is expected that about 62 will result in at least 9 flights being on time. Okay, now if we wanted to do this on the TI-84 calculator, then what we would do is we would take the value of 1 and then we would subtract the probability of x being less than 9. And if you recall, this is going to be 1 minus the binomial, okay, and that's CDF, cumulative, of when n is 11, our probability is 0.80, and we are using 8 because this is less than. Okay, so let's go ahead and do that. Okay, so we're going to take 1, and then we're going to subtract, and then second distribution, we're going to go to binomial CDF. We know we have a number of trials 11, probability is 0.80, x is 8, and then paste. So we're going to take 1 and subtract that result, and you can see that we get 0.164. So 0.614. So 0.6174. Okay. And then let's also do this on StatCrunch. So I'm going to kind of scroll down here a little bit. Okay, so if we use this on StatCrunch, okay, we know we have a number of trials of 11. We know that this is 0.80. Now on StatCrunch, you don't need to put the 1 minus. You can just put in the greater than or equal to 9 and then select compute. And then when you do that, you get the following result. So therefore, StatCrunch, and let me go ahead and make a little bit more room here. Would then give you this result here. Okay, let's move on to part F. It says find and interpret the probability that between 7 and 9 flights inclusive are on time. So what does inclusive mean? Well, the word inclusive means including. So determine the probability that 7, 8, or 9 flights are on time. So what that means is, okay, we're finding the probability that X is going to be in between 7 and 9, which means we're finding the probability of 7 or 8 or 9. So we're looking for the probability of 7 plus the probability of 8 plus the probability of 9. Okay? So let's go ahead and do that. Well, the probability of 7 and 8 and 9, okay, we have already found. So we can come back up here. We know that we already found the probability of 9, which is this number here, 0.29527. We also found the probability of 8 and the probability of 7. So what we can do is we can take this number, okay, and we can add that up. So if we add all those numbers up, then we would get the following probability. So that would be 0.6275. Okay, now if we wanted to use the TI-84 calculator here, okay, what we would want to do is, again, finding the probability that X is going to be in between 7 and 9, we would have to do the following. We would need to take the binomial cumulative CDF of 11 trials, probability of 80%, and then starting at 9, and then we're going to subtract the binomial CDF, which is again 11 trials, probability of 80%, and then 6. Okay, why? Because, okay, for the binomial CDF over here, for this one, this is going to represent 9, 7, 8, and then 6, ... Okay? And over here, this is going to represent 6, and then ... Okay? And what we want to be able to do is we want to subtract that part. So in order to do that, we want to be able to subtract this part from this result, to then when you add up 9, 7, and 8 on the calculator, it's going to give us that answer. Okay, so that just gives you an explanation as to why. So let's go ahead and put that in our calculator. Okay, so we're going to go ahead and go second distribution. We're going to go to binomial CDF. Okay, we know that 11 trials, the probability is 80%. We're going to start with 9. And then select paste. So we have it in our calculator. We're going to select subtract. Now we're going to go back to second distribution. And then we're going to go back to binomial CDF. Again, 11 trials, 80%. But now we got to change this X value to 6 because we're subtracting that. And then select paste. Now that we're subtracting that, we're going to select enter. And then we should get our same result that we got there, which if we round this to 4 decimal places, then you will see that we get 0.6275. Okay, so that gives us the same result, 0.6275. Now, if we wanted to then use StatCrunch, okay, let's go ahead and do that. So with StatCrunch, okay, now here we're looking for between, okay, not the standard. So we're going to select between. So we know that n is equal to 11. We know that we have the probability of 80%, and we know it's going to be in between 7 and 9. So select compute, and then we can get our results rather quickly using StatCrunch. Okay, so therefore there is our StatCrunch way of getting our information. Now, it's telling us here that the probability of 0.6275 is for one trial of this experiment. We're going to multiply by 100 to compute the number of trials of this experiment in 100 that are expected to result in the desired outcome. So we're going to take 0.6275, we're going to multiply that by 100, which is going to give us 62.75. Round that to the nearest whole number is going to give us 63. So therefore, we'd say in 100 trials of this experiment, it is expected that about 63 will result in between 7 and 9 flights inclusive being on time.